Hello, we are going to be talking about the scientific method today. The scientific method is a proven procedure that has been used by scientists since the 17th century. It is a series of steps to help scientists determine fact from fiction. Now, although there are many steps, as you can see, to this method, we will go over all of them, and we will start at the starting point, which is asking a question. You need to ask a question in order to focus in on what you are trying to figure out. What is the problem? What are you trying to accomplish? What is the problem? You have to ask a question so you know where to start. After you ask this question, you need to gather information. And most information is gathered by making observations. Now, observations with the chemistry definition, since in physical science that's where we're starting with, is chemistry, is an act or instance of viewing or noting a fact or occurrence for some scientific or other special purpose. Uh, we make these observations in the natural world. Sometimes it's in a lab, sometimes it's just by watching what's going on around us. We use these observations to make a hypothesis. A hypothesis is basically your best guess as to why what you are observing is happening. You take all that observational data that you collected and you say, I think this is what's happening. Now, hypotheses are usually phrased in an if-then statement. If this happens, then this will happen. But it is basically an educated guess. We then take this hypothesis and we use it as the driving force behind our experiment. We are trying to either prove our hypothesis right or prove it wrong. In science, it doesn't really matter which one you do, because from both of them you are going to learn something new and therefore to better understand what's going on. So in our experiment, we have a couple of different variables, which we will touch on in more detail later on in the course. But we have the independent variable, which is what you are changing in the experiment. The independent variable affects the dependent variable, which is what we are going to be measuring during the experiment. And then we have constant variables, which are the things in the experiment that are always held to be the same. They will never change. We have these constants so that we are only really focusing in on one thing, which is the dependent variable. How is that changing? So if everything else is staying the same, it's much easier to see how that dependent variable is changing. From there, the experimenter takes this information and collects this data. He then organizes it into tables, graphs, charts, whatever makes it easier to understand what's actually happening during this experiment. He puts it in a form that allows him to see the patterns, or maybe see that there is no pattern, so that he can more easily digest the data that has been gathered. And then this information is used to form a conclusion. So you asked your question, you made your observations, you made your hypothesis, performed your experiment, collected your data. Now you have all this information and you need to form it into a conclusion. Now, after you've made your conclusion, whether you say your experiment was well and good and your hypothesis was absolutely correct, or that your hypothesis is wrong, either one is okay, you should always communicate your results, regardless of whether it was good or bad. Because like I said before, even bad results teach you something, and they allow other people to learn from your mistakes. So it's not just you learning from what you did wrong, it's other people also learning what they did wrong, so they don't have to repeat it themselves. In order to verify results, the experimenter should always retest. Doing one experiment is not good. You want to have more than one. You want to have more data to back up what you say. Just doing it once doesn't cut it in science. You have to do it many, many, many times over. And normally it's not just one person doing it. You will have a couple of different people, or maybe tens, 20, 30, hundreds of different people doing it. It depends on what we're talking about. But you always need to retest. So that is the scientific method in a nutshell. We will dive more deeply into it later on, but thank you for listening.